Good morning, students. Today's class is about satellites. Everybody knows about the word satellite because we have heard about satellites, both natural and artificial, right? For example, that's any body which is moving around a planet is called a satellite. And everybody, even a small child, also knows that moon is the natural satellite of the earth. Am I correct? We can say that earth is but because in the case of a sun and other things, we don't say that they are satellites, but they are called planets. But the bodies which are moving around planets are called in fixed orbits. That means always these satellites are moving in fixed orbits. Their orbital radius will be always same, and is going on rotating, revolving and all. From the time of creation of the universe to till date, every planets are having satellites are moving in their own fixed orbits, right? So there are natural satellites and also artificial satellites. Artificial satellites, we have two types of artificial satellites we have. That is, one is polar satellites and they are equatorial satellites. Equatorial satellites are moving in the equatorial plane of the earth. And while polar satellite is moving around the pole to pole, moving around the earth. Am I correct? Both these satellites have different uses. For example, polar satellites are used for scanning the earth, because when the body moves around the earth pole to pole around, then that will be focusing every point on the surface, the poles, equatorial position, any position of the earth will be scanned out of that. So it can study about the vegetation, it can study about the animal life on the surface of the earth, it can study about the water resources of the earth, so many things about the polar ice caps, what is happening there, everything can be scanned and studied a clear picture. We can see a clear picture of what is happening on the surface of Earth with the help of polar satellites. Right? Polar satellites, it is very difficult to install. Even India has a polar satellites, right? Polar launching vehicles we have. Polar satellite launching vehicles we have, and also we have what is called this equatorial satellites. Equatorial satellites are most of the time used for communication purposes and also spy work also. Both the satellites can be used for spy work also. So satellites are very useful man-made objects which are set into the orbit of the earth. In fixed orbits, these bodies are moving. They are called artificial satellites. In artificial satellites, sometimes they are also called as geostationary satellites. Geostationary satellites are those what is called equatorial satellites whose time period is also 24 hours as that of the time period of rotation of the earth. So when you stand at a particular place and see a what is called this equatorial satellite, we see that satellite is standing at a particular position. It is actually not standing at a particular, it is also moving. But we and the observer and the satellite both are moving with the same speed. Therefore, we see that satellite is always stationary, right? They are also called as geosynchronous satellites. Geosynchronous satellites are satellites having same time period as the time taken by the earth to complete one revolution. That is why they are called geostationary satellites. We also have installed so many geostationary satellites in our space, in our atmospheric space. Right? This is about satellites. There are so many techniques used for installing satellites in the fixed orbit around the earth. Am I correct? So satellites and their uses are very important. You can read and collect more and more ideas from the textbook also, right? So these are about satellites. Now satellites, everybody knows that satellites are orbiting around the planet in fixed orbits. The velocity required to put a satellite or install a satellite so that it can move in a fixed orbit is called its orbital velocity. Now we are going to derive orbital velocity. Orbital velocity means the velocity required by a body to move in a particular orbit around the earth is called orbital velocity. It is most of the time it is denoted by small v and a o at the right bottom corner. right? Suppose a satellite of mass small m is revolving around the orbit at a height h above the surface of the earth. Let the mass of the earth and its radius are capital M and capital R. This is the earth, and around the earth a satellite of mass small m is rotating like this with a velocity v. Actually we have to write VO here, right? I forgot to write VO here. Most of the time when I write notes I make silly mistakes. Please understand me, right? So please don't take it otherwise sir did a mistake, that is why I am mentioning it. You will write VO, right? Yeah, here the direction of orbital velocity is along the tangent. Any body when moves in a circular path, the velocity, direction of the velocity is along the tangent placed at that particular point. Right now the centripetal force required is equal to mv square by r. Any body moves in a circular path and is always remaining the circular path, means a centripetal force is always acting on that body. In this case, the satellite is moving around the earth in a fixed orbit. It is a circular motion. For any circular motion, centripetal force is required. Centripetal force is equal to mv square by r. Here it is r plus h. Why? Because this body of mass m, small m, is at a height h above the surface of the earth. The distance of the satellite from the center of the earth is equal to r plus h. That is why in place of r, mv square by r, in place of r we are taking r plus h. Here the centripetal force is, who provides centripetal force? Centripetal force is not a force which is coming from down from anywhere, but already the force is there. What is there? What is the force between this and this? That is gravitational force of attraction. In this case, centripetal force is provided by gravitational force of attraction between the earth and the satellite of mass small m. What is that mass? That is why we can say that centripetal force is equal to gravitational force of attraction. Gravitational force of attraction is equal to G capital M small m divided by R square. In place of R square we will write R plus H the whole square. That is why mv square by R plus H. Centripetal force is equal to the gravitational force of attraction. We will cancel r plus h and 1 r plus h there, and m cancelled. Then v is equal to root of gm divided by r plus h. We can write this is VO. You don't forget write a O here. VO, right? VO, by that letter I mean orbital velocity. Please don't forget the notes also you are getting nowadays, right? Another technology we are using, V0 is equal to root of gm divided by r plus h. So for a satellite very close to the earth, very close to the earth means this small h, this is not n, small h. If it is very less, that means the satellite is moving around the earth at a very closer orbit, h can be neglected. So h is neglected, then VO is equal to root of gm divided by r, because h is neglected. Why h is neglected? Because we are taking a satellite which is revolving around the earth in a closer orbit. But we know that g is equal to gm by r square. Therefore gm is equal to gr square also we can write. There is a very simple thing, right? Therefore VO is equal to root of gr square, because gm, in place of gm I am writing gr square divided by r. That is equal to rg. This is the only thing. And from equation 1 also r plus h, that equation also again same thing you will get. Also v is equal to gr square divided by r plus h. That is this r square when come outside the root you will get r only, r into root of g by r plus h. Am I correct? If h is very much, when I write h, this line gets shortened. Please don't mind, this is h only. When h is very much less than r, h is neglected, then this is equal to what is called r into this r is as it is divided into root of g by r only, h is neglected. When this r is taken inside, that becomes equal to gr square divided by r. You are getting, anyway you will get the same value of orbital velocity. Orbital velocity is equal to root of gr. Any satellite which is very close to the surface of the earth, when it rotates around the earth, the velocity can be calculated by putting the values of small g and also small r. Everybody must know that the radius of the earth is equal to 6.37 into 10 raised to 6. It is not minus 6, 10 raised to 6 only. So 10 raised to 6 meters. Am I correct? Therefore, 9.81 g, r is equal to 6.37 means 6.4 we can take. 6.4 10 raised to 6 is equal to, that is equal to 8 into 10 raised to 3 meter per second. Because any satellite which is very close to the earth, you see very surprising things it is. This satellite is moving with a very high speed. How much it is? 8,000 meter per second. In 1 second, it will travel 8 kilometer. Satellite motion is a very speedy motion in the circular path. So, this is a very interesting thing. Any satellite which is very close to the surface of the earth, at least its velocity must be 8 kilometer per second. This is about orbital velocity. Orbital velocity is the velocity of the satellite which is moving around the earth in a fixed orbit. Next is called escape velocity. You know, everything on the surface of this is attracted towards it. There is a gravitational field also around the surface of the earth. Within the gravitational field, if any object is placed, that is attracted towards it. Am I correct? Okay. If we throw an object on the surface of the earth, we have to give a very high kinetic energy. Then only the body can overcome the gravitational force of attraction and will escape once for all. Once for all means for permanently that will go out of the gravitational pull of the earth. That velocity with which a body is projected, or that minimum velocity, if a body is projected with that velocity, the body will overcome the gravitational pull of the earth and will escape out of it. That velocity is called escape velocity. Escape velocity is the minimum velocity with which a body is projected. Then the body will overcome the gravitational pull of the earth and will escape permanently from the earth, and it can never come back. And this velocity is called escape velocity. Escape velocity is also a very important topic in this year, right? So, escape velocity of a body is the minimum velocity with which it is to be projected so that it just overcomes the gravitational pull of the earth and will escape out and will never come back. This is denoted by V, small v and a small e. The other one was V and a small o, orbital velocity, and this is escape velocity. In order to project a body with its escape velocity, we have to give a kinetic energy. We have to increase the kinetic energy and throw it from the surface of the earth. Then only it can escape out of the gravitational pull of the earth. Consider the earth to be a sphere of mass m and radius capital as shown in the figure. Right? Suppose a body of mass m is to be projected upwards with the escape velocity v. Right? We are taking two things. One is the earth. Earth is having a radius r. Right? And we wish to project, throw a body of mass small m with a velocity v so that it escape out of the gravitational pull of the earth and will never come back. Right? Okay. When the body of mass small m is at the point P at a distance x from the center of the earth as shown in the figure. So, this is x from the center of the figure. Suppose that a body of mass small m is placed at the point P at a distance x from the center of the earth. Am I correct? Okay. So, suppose if the body of mass m is placed at this point, small m is placed from the surface of the earth. What is the mass of the earth? Is capital M. Mass of the body is small m. The small m is placed away from the body of mass capital M. What is the force acting on? Force acting on the body of mass small m is given by F is equal to G capital M small m divided by x square. Everybody knows, right? Let the body m is moved through a small distance dx in a direction opposite to the attractive force. Opposite to the attractive force means an external agency has to do some work. Energy will be stored positively. If it is brought towards it, energy is lost by the body. That is why in the potential energy condition when we described there was a negative sign. In this case, there is no negative sign is coming because an external agency You can throw a body because you are doing work on the body. That work is actually stored in the body as a positive energy. So suppose the body of mass m kept at point P is shifted through a small distance dx, the work done is equal to force, the small work done is equal to small work done, because the body is shifted through a small distance dx. The small work done is equal to what is called dw. dw is equal to f dx is equal to force into distance. What is the force? Gravitational force of attraction. Force into displacement. Force is g capital small m divided x into dx. The work done in moving the body from r to infinity, that means from the surface, within the field of the body, if a body is taken to a small distance, the small work done is this much. If so, if the body is taken from the surface of the earth to an infinite separation, what is the total amount of work? You have to do only integration. This must be the slogan every time. When a small value is obtained, the big value can be calculated using integration. That only we are doing here. Therefore, the total work done in shifting the body or throwing the body from the surface of the earth to infinite point. Infinite point means what? Out of the gravitational pull of the earth. The total work done is given by integral r to infinity g capital M small m divided by x square into dx. So constants are taken outside g capital small m into integral r to infinity x raised to minus 2 dx. Why that? Because 1 by x square is equal to x raised to minus 2 dx. Am I correct? This when integrated you will get, as we did in the last case, g capital small m into integral into this x raised to minus 2 when integrated x raised to minus 2 plus 1 divided by minus 2 plus 1. You will get minus 1 by x you will get. Am I correct? That is why you are getting that this is equal to this is equal to minus 1 by x you are getting, right? That means you are getting this as equal g capital small m into minus 1 by x within limits r to infinity. Now the limits have to apply. Limits means upper limit minus lower limit. So write once again g capital small m into what? Apply the upper limit minus 1 by infinity. Minus of minus 1 by r. In place of x you will put r, because the function is minus, that is this minus is there, right? This and this cancelled, minus and minus is equal to capital R. Therefore you are getting as this as equal to g capital M small m divided by r. G capital M small m divided by r. Am I correct? So this is the condition. Now, but the work done is equal, work done on any body is equal to kinetic energy. Which theorem? You call it as work energy theorem. Work done is equal to kinetic energy. Work done is G capital M divided by capital M small m divided by R. That is equal to kinetic energy. This is work done, that is equal to kinetic energy. Kinetic energy means with what velocity the body is projected? With escape velocity. At escape velocity, what is the kinetic energy? Half m into v square is equal to g capital M small m divided by r. M and m cancelled and v is equal to root of 2g capital M divided by r. Now again we know that gm is equal to gr square. Putting the value here, you will get 2gm. 2gm is 2 into gr square divided by divided by what? Divided by r only, r and r cancelled, you will be getting root of 2rg. So escape velocity v is equal to root of 2gr. In the case of the earth, escape velocity is equal to 2 into g is equal to 9.81 into 6.37 10 raised to 6. When you do, you will get the value is equal to 11.2 into 10 raised to 3 meter per second. This is equal to 11.2 kilometer per second. Am I correct? That means if a body is thrown from the surface of the earth with the velocity 11.2 kilometer per second from the surface of the earth, it will go out of the gravitational pull of the earth and will never come back. That means for the earth of ours, the escape velocity is equal to 11.2 kilometer per second. So this is orbital velocity explained, and also what you call escape velocity also I have explained. Now you will see that V is equal to root of Rg, V is equal to root of 2Rg. That is, this is root 2 into root Gr. That means root 2 into VO. That also from my voice you will write. That means VE is equal to root 2 VO. Root 2 VO. Root 2 into VO separately. VE is equal to root 2 into root GR. Root GR is equal to VO. Therefore, VE is equal to root 2 VO. That's also very important relation. Am I correct? One more thing you have to see is that the escape velocity is independent of the mass of the body. Any body is thrown out, whatever mass there be, but the velocity is always same. A big body and a small body both are projected outwards with the same velocity. That means that will go out of the gravitational pull independent of the mass of the body. All the bodies are having the same escape velocity on the surface of the earth. That is equal to 11.2 kilometer per second. This is this lesson about, and the next day we will come with a new topic. Till then, bye bye. Thank you very much.